Designing an AD site topology. Now, this is where the rubber meets the road. It's where the physical layout of your network collides with the logical organization of your domains and forests, and it impacts replication as well as things like simple user authentication. It's a really important topic. We'll be covering the basics of site topology design, and we'll be focusing on a few specific goals, including domain controller proximity, the balancing between replication speed and WAN bandwidth usage, the creation and utilization of site links and site link bridges, and how Active Directory deals with replication conflicts. Now, as always, because this is a design level nugget, we're not going to talk about some of the how-to things. You should already know those, and if you don't, then the 7412 exam series is the place to find it. We're going to talk about why you configure sites and site link bridges and site links and stuff, but that series will show you how to actually do it, what buttons to click to make it happen. That also covers how to manage site coverage, how to manage the related SRV records in DNS, and how to move domain controllers between sites if you need to do that. So you should already kind of have that knowledge under your belt already, and we're going to talk about why you would actually do any of those things. So we're going to start by looking at overall site topology design. Now, to do that, we need to start with a diagram like this one, which reflects the physical connectivity in my environment. So we'll start with the LA office. Now, this is clearly our company's bigger office. It has 3 local area network segments. I've just put a portion of an IPv4 address in here to kind of differentiate between those segments, .6, .5, and .7. All of those are connected by a router. Now, the point is that all of those they enjoy high-speed connectivity to each other. In other words, it's all LAN quality bandwidth. I would imagine it's at least 100 megabit Ethernet. These days, it's possibly even gig Ethernet all the way out to my desktops. I'm not really worried about my desktops so much, though. The point is that any domain controllers that are located in the LA office are going to have a high-speed, uninterruptible local area network connection right to each other. That's the important thing. So that's the LA office. Now, the rest of the offices appear to be smaller offices. We've got New York, DC, London, Sydney, Hong Kong, and Tokyo. Each of them just has one local area network segment. So I'm thinking these are smaller, maybe branch offices, small offices with only about 100 users. Because they're so distant, I imagine that they have a domain controller in each one of those things, but that really doesn't matter for our purposes here. The important thing is that they have a single LAN segment to work with. Now, they are connected to each other and to the main LA office by a wide area network link. You can see that the LA router has different links going on, and I'm calling these solid orange lines high-speed WAN. This might be a dedicated T1 or maybe even better connectivity off to each of these. Now, the LA office does have slower connectivity off to the Sydney office. I'm guessing we weren't able to affordably get that same quality of WAN bandwidth off to them. So that might be something like an older ISDN line or something that's in our relative opinion, something that's of lower quality than the other wide area network connections. Now, to help supplement that, we clearly do have a high-speed wide area connection between London and Sydney. Now, the LA office is not connected to the 2 Asian offices directly. Sydney is connected to Hong Kong, and Hong Kong has a line off to Tokyo. So there's a few different hops that are going to involve in getting traffic from one place to another. So this is the basic physical network connectivity that we're dealing with. And the job of an Active Directory site topology is to overlay on top of that, and in the beginning at least, to describe as accurately as possible to Active Directory what our physical connectivity actually looks like. When it comes to Active Directory replication between domain controllers, within a single site, you have no control. Within a site, because the presumption is that the site consists of high-quality LAN bandwidth, you don't get to control how replication occurs. Replication occurs more or less continuously at very frequent intervals between all your domain controllers. What you do have control over is replication between domain controllers in different sites. So if we've got domain controllers in each of our sites, we're going to have to build site links as well as define our sites to Active Directory. So the first step is to actually define the sites. And the way you do that is by telling Active Directory about each of your subnets, and then telling Active Directory which subnet belongs to which site. So we would create an LA site that included the .6, .5, and .7 networks. Subnets, we would define a New York site that contained .20, a DC site that contained .30, and so on. So you actually do that in the Active Directory Sites and Services console. You'll set up all of those sites. In fact, let's look at how to do that. So this is the Active Directory Sites and Services console, something you should already be familiar with. And you can see that I've started creating the sites. There's a couple here that weren't shown on my diagram, and I'm getting the ones like LA and London and Sydney all put together. Now, once I've got my sites created, I can go in and start creating subnets. And if you look at all the subnets, you'll see that when I create a subnet, I have to give it the IPv4 prefix as well as the bit length of that, so that tells it what the subnet mask is, and then I tell it what site it belongs to. So that's how clients figure out what site they're in, and they'll look for a domain controller that's in the same site. And you can see that each site can consist of multiple subnets if necessary. The other cool part about this is that you can get in once you've done it, and you can see the servers that have identified themselves as being in that particular site. So they'll do that based on their IP address. So you go in, create the sites first, then you create your subnets, assign each subnet to a site, show you where that is, open this thing's properties, stick it into a site, and you're good. You can fill in some other location about, or other information about where it is, like the location. You can, set security on this link. And you can also, if you right-click on the folders, you can delegate control over this. So if you don't necessarily need your domain admins to be spending a lot of time, messing around with subnets and sites, maybe you've got an infrastructure team that actually deals with IP addresses more directly, you can delegate control over this to them, let them set up subnets. They won't be able to set up the sites because the sites aren't contained in this folder, but they would be able to set up new subnets and indicate which site the subnet was in. So you can actually kind of get someone else helping you to maintain this entire infrastructure. Now, the creation of those sites and defining what subnets belongs to each plays an important role in how clients log on to Active Directory. By default, a client computer will attempt to find a domain controller in its own site. That's not the same as its own subnet. For example, in LA, we probably have clients on a couple of subnets while we have all of our servers on another one. But they're all in the same site because we've told Active Directory that when a client computer logs on and it gets an IP address, probably from DHCP, it will use that IP address to figure out what subnet it belongs to. It then knows what site it belongs to, and it will prefer to find a domain controller in its own site. Now, if there isn't a domain controller in its own site, or if there is but that domain controller isn't responding for some reason, then it will go out of site, and it will follow similar rules to what replication would follow. And that's why our next task is to create site links that tell Active Directory what our actual WAN bandwidth looks like, what our WAN architecture looks like. So I'm going to draw these in red. We're going to create a site link from here to here. And each site link gets assigned a cost. The lower the cost, the better the link in terms of bandwidth. The more we want Active Directory to use that one in preference to others. So since this is a high-speed link between LA and New York, I'm going to give it a cost of 1. I'm going to create another site link between LA and DC with a cost of 1. Another one between LA and London with a cost of 1. I'll create another site link between LA and Sydney, but I'm going to give this one a cost of 5. And that's because I really am uncomfortable with the bandwidth I've provided between LA and Sydney. And, quite frankly, if we never use that bandwidth, I'm going to be okay with it. There is a connection between London and Sydney, and let's give that one a 2. Maybe it's not as good as the other ones we've got in the US, but it's pretty good. It's certainly better than the one between LA and Sydney. From Sydney to Hong Kong, let's call that one a 2 as well. And Hong Kong to Tokyo, we'll call a 1. So now Active Directory knows how our sites are physically connected to each other. About the worst thing you can do is create a site link where a WAN does not actually exist. For example, and I'll draw this in a different color because I want to emphasize the wrongness of it. You would not want to draw a site link between LA and Tokyo at any cost because you don't physically have connectivity between LA and Tokyo. So never, never, never. Now, how does Active Directory going to work with the replication between all these? Well, it's probably best that we actually permanently update our diagram to represent the site links we've created. Fortunately, I've already done that for us. And just to make it a little bit easier to see, I've dimmed out the physical network architecture, so we're just left with these lightning bolts that represent the site links that I've created between them. So here's how replication is going to work. Let's say we make a change to a user object in LA somewhere. Doesn't really matter where. Now that change has got to propagate out to all the other domain controllers we've got. For the sake of argument, let's say that we've got a domain controller in each of our offices. Now replication is going to try and take the cheapest path possible. Now that means it's going to replicate to New York, it's going to replicate to DC, and it's going to replicate to London. Now at this point, it knows it still needs to get the change over to Sydney, and it's got two ways of doing so. One has a cost of 5, and the other has a total cost of 3, because it has to go from here to London and then over here to Sydney. So 1 and 3. In reality, what's going to happen is it's just going to replicate this first one to London, and then London is going to replicate with Sydney. This 5 link is never going to get used at all because it's simply too expensive. Now, if the link to London went down for some reason and the only way to get to Sydney was via this expensive link that costs 5, well, then it would do it. It would use that link, and then Sydney would replicate back to London, keeping it connected. Now, once it's in Sydney, it's going to go out to Tokyo or Hong Kong, and then from Hong Kong to Tokyo. You can see, though, that we wind up with a multiple hop replication system. In other words, in order for something to get to Tokyo, LA will not replicate directly with it. That's a really important concept. LA will not talk directly to Tokyo. It'll talk directly to New York, it'll talk directly to DC, and it'll talk directly to London, and that's it. The total cost to get something to Sydney is cheaper if LA doesn't do it. And that means there's going to be a little bit of a lag time by the time something gets to Sydney. And there's going to be a little bit more of a lag time for it to get to Hong Kong, and a little bit more of a lag time for it to get to Tokyo. And that's okay, because that's what our physical WAN architecture is actually allowing us to do. Now, from an operational perspective, we might not be so happy about that. We might not be happy about the fact that in order to replicate a change out to Tokyo, it's going to take a total of 1, 2, 3, 4 hops. So now we can kind of make a decision. We can decide what we think about our WAN bandwidth, and we can start to make a balance between our desire to have things replicate faster and our desire to avoid overloading our wide area network architecture. And that compromise in Active Directory's world is called a site link bridge. So what we're going to do is create a bridge that encompasses this link, and it's going to allow LA to replicate directly with Tokyo. We're going to assign a cost to that. Now, the default cost is the sum of all the links, 1, 2, 2, and 1. We can assign a lower cost to that if we want to. We can do whatever we want to do. Keep in mind, LA's domain controllers are now going to contact Tokyo's domain controllers directly. So the replication is only going to take 1 hop, but it still has to traverse this underlying physical network. What that means is when replication needs to happen, here, let me turn back up the color. So once I've created that site link bridge, LA is going to talk directly to Tokyo's domain controllers, but it still has to follow my physical WAN architecture. right? So it's going to have to go across all those physical hops in order to directly communicate. And what that means is I'm going to have replication happening twice across this particular link. My replication has to go from LA to London and from LA to London, Sydney, Hong Kong, Tokyo. Replication is also going to be happening twice over this link, as the London domain controllers talk to the Sydney domain controllers, but that same replication traffic is flowing from LA through to Tokyo. This link is also going to be doubling up because Sydney is going to be communicating with Hong Kong, and LA is going to be communicating over that same link to get to Tokyo. Now, because of the way we've set up our costs, it's possible. Let's take a look at this here. The cost to communicate with, to use the WAN link for London is 1, so that's 1 there. This is going to cost 2. This would cost 2, but if LA is already communicating with Tokyo, then Tokyo might actually wind up replicating to Hong Kong. So that might save a little bit of traffic there. It means this is only being used for the LA to Tokyo pass-through, and then Tokyo can communicate back, but it means this link is doubling up because Tokyo is communicating back to Hong Kong. So whenever you start creating these site link bridges, whenever you start telling one site's domain controllers that it's okay to talk directly to another site's domain controllers, kind of ignoring your WAN architecture, you are creating additional WAN bandwidth, and you make your replication topology a little bit more difficult to predict because you really have to sit down and do the math. Now, unfortunately, Active Directory does not have any built-in native tools that let you view the actual topology that Active Directory has chosen, not in a graphical form. There are third-party products out there that they'll draw you a view not dissimilar to the one we're looking at right now, which I've done in Visio. They'll kind of draw out your topology as Active Directory sees it. And if you've got a really complicated site topology, one of those tools can be incredibly useful for troubleshooting. But the point is, as soon as you start dragging site link bridges into the mix, you really do complicate things. You know, if your operations team said, wow, you know, this link from LA to London, we're not getting a lot of love off this. It's really, really saturated all the time. And we've done some sniffing, and it looks like there's a lot of Active Directory replication traffic going across it. What's up with that? Well, you might say, gosh, I'm looking, and there's just the one site link that's been created. Make sure you're also looking at site link bridges, because you might be utilizing that WAN link more to support additional site link bridges. Now, I've certainly been in environments where they've said, you know, we want replication to go as fast as possible, so we're going to have direct connectivity to every place where we're actually connected, but then we're going to, and I'll draw this in a different color for you, we're going to bridge this connection, and we're going to bridge this connection, and we're going to bridge this connection, so that our LA domain controllers are talking directly to the domain controllers in every other office. Well, the problem is there's still only one actual wide area network line getting you there, and you've just 1, 2, 3, 4 quadrupled the traffic across that thing. That's fine if your operational goal of faster replication has precedence and if your WAN bandwidth can support it. I'm not saying that's a wrong thing to do, but I am saying it's something you need to think about. You don't just turn that on so you can speed up replication without also thinking about the consequences. Now let's take a look where those site links and these site link bridges exist in Active Directory. So we're back in the Active Directory Sites and Services console, and we want to look at our site links. This shows up under Intersite Transports, and I've got my IP links here. I tend to name my links to indicate which two sites they connect. So I can clearly tell that this site, based strictly on its name, represents my LA to London link. This is my LA to Sydney link, and this is my London to Sydney link. You'll see that I've configured a cost for each of these as well. The default is 100, and it really doesn't matter what number you use. It's just all about relativity. It will try and use the cheapest route by adding these up. So I usually, in my head, I'll kind of come up with my own internal standard. Like a T1 always costs this much. A dial-up link always costs this much. A frame relay link always costs this much based on its bandwidth. And then for each link, I'll adjust that number based on how loaded I think that link already is, and so forth. So it's just all about relative comparisons. Now, the other thing a site link lets you do, if you remember, I said within a site, you cannot control how often domain controllers replicate to one another. That's true. I still stand by that. But across site links, you can. For example, London to Sydney is only allowed to replicate every 2 hours, every 180 minutes. And I can even change the schedule on that. So let's say I know, for example, that I don't have a lot of things going on between certain hours. I don't have a lot of administrative changes occurring. I'm not really worried about replication. But I do have some other processes that are using the WAN link, and I want Active Directory to stop it. So I'll just unavailabilize those hunks of time, whatever they are, and then replication won't run during that time period. But man, make sure you document that someplace. Don't lose track of that information, because otherwise, things will change. You'll move on to a different position, or whoever set it up moves on and you're the one who moves in. You don't realize all that's there. And suddenly somebody asks you why they made a change at midnight and it didn't replicate until 5 the next morning. Well, you need to know that there's a schedule associated with this. In fact, one of the first things I do anytime I go into a site, if I'm going to be responsible in any way for dealing with Active Directory and replication, I go in and I look at the site links and I look at a schedule and I draw myself a map in Visio if they don't already have one. And on that map, I put the replication schedule so that I can see it right in front of me at all times. So that's a site link. You can tell it what sites are in the link. So the next thing I could do, if I wanted to, is create a site link bridge. And this comes into the same area. Now, I know in the diagram I wasn't putting one into the the LA Sydney side, but that's what I'm going to do. Here, I'm going to say LA, London, can't type, Sydney. So that whole hop from LA to London to Sydney is going to be represented by this. And I'm going to put the LA to London and the London to Sydney link in there. And that's a site link bridge. We look at the properties of this. It's not all that complex. There's not really much to configure. The trick is information now needs to go from LA to Sydney, and it can do it over this bridge. It can talk directly to Sydney. It does not have to go from LA to London first. It will utilize this, but it is still governed by the combined cost of its constituent links. So the LA to London is 1, and the London to Sydney is 2. That's a total of 3. That means it will not use that low bandwidth direct LA to Sydney link, which has a higher cost of 5, and that's the way I want it. But if my network connection to London was interrupted, this is still there as a backup. 5 is more expensive than 3, but 5 is less expensive than not available. So that's one of the reasons these link costs can become important. The only thing I don't like is that the GUI doesn't show you what the total cost is. You have to kind of add up the constituent cost in your head. But again, when I'm creating diagrams, I'll include those site link bridges and I'll put the total cost that I've calculated there so that I can actually have something to look at where I can start to make some predictions about what I think Active Directory is going to try to do when it comes to replication. Now, I told you earlier that in addition to replication, your site topology is used to help clients find a domain controller, and that by default, a client will attempt to find a domain controller that's located in its own site. If it can't find one, either there isn't one or there is one but it's not responding, then your client will go to another site to try and log on. Now, if you have a domain controller that's running Windows Server 2008, 2008 R2, or Server 2012, you can make it possible for your client computers, if they're running Windows Vista, Windows 7, or later, to locate a domain controller more efficiently. There's a try next closest site group policy setting, and what it does is it improves the domain controller locator function in the client, helping to streamline your network traffic, especially in large enterprises that have a lot of sites and a lot of branch offices. What the new setting does is affect how you configure your site link costs, because it affects the order in which your domain controllers are located. If you've got a lot of hub sites with branch offices that come off of those as spokes, you can really reduce that Active Directory authentication traffic by allowing clients to fail over to the next closest hub site when they can't find a domain controller in the closest hub site. As much as possible, you should simplify your site topology and your site link costs if you're going to enable this. If you've got a lot of hub sites, it can help simplify your plans for handling situations where clients in one site do need to fail over. So this isn't turned on by default when it's not enabled. So when you're not using this, the default, the DC locator algorithm uses the following approach. It will try to find one in the same site, and if it doesn't find one in the same site, it will try to find any domain controller in the same domain. By turning on next closest site, you add a little bit more intelligence. So let's take a look at where you would turn that group policy setting on. Okay, so in the group policy management console, you're typically going to configure this policy, if you choose to use it, at the top level of your domain because you want it to apply to all of your clients. Now, it should maybe go without saying, but I'm going to say it anyway. Your clients have to log on to the domain at least once after you make this change before they will be able to use this capability because this setting has to be applied. So since I want this to hit everybody, I am going to edit my default domain policy. That's already linked. It's already hitting all of my users. And this is a computer setting. Well, let's see if I can remember where this stupid thing lives. Computer configuration, policies. It'll be under administrative templates. Be under system. Should be under net logon. And, oh, there it is. DC locator DNS records. That was easy. And now we just need to find the enable next closest, try next closest site. There it is. Open that up, enable it. There's no options. It's just either on or off. There's a pretty good description of what it does in there. Now all of my clients will have that capability enabled. And the next time they need to log on, if they can't find a domain controller in their site, they will try the next closest site rather than just kind of randomly reaching halfway across the world, potentially across 8 dozen WAN links to find a domain controller. So a couple of little tricks and caveats. That next closest site thing is useful. However, a read-only domain controller does not count. So if the next closest site only has read-only domain controllers, then that site will not be considered by the next closest site algorithm. Another concern that you have to layer on top of all this is that all of this site topology stuff exists per domain. And it's around domain controllers, right? So if you've got, let's say, 2 domains, we're going to say the blue domain has a domain controller here, 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 and here. And the red domain has a domain controller, oops, red, I said. Red domain has a domain controller here, 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 and here. Well, that's going to really kind of change how replication works. Keep in mind, obviously, domain controllers can only replicate with domain controllers in the same domain. We've still got the same WAN connectivity, and that's shown by the orange links. So you're going to have 2 overlaid site topologies, one for each of the domains. That means there's going to be traffic going through here, traffic going to here, probably traffic going from here, and then traffic going through here to get to there. On the blue side, looks like we're going to replicate across this. Looks like we're going to be coming down here to London. And we're going to be going probably through London, through Sydney to get to Hong Kong. So as soon as you start adding more domain controllers to the mix, you can significantly complicate your overall site topology. Not so much complicate the topology, I guess, because each domain is still going to have a pretty straightforward topology. It's just the consideration of what that's doing to your WAN traffic. Right? Again, if your operations folks come up and say, wow, the WAN is just being decimated, well, yeah, that's because we've got 2 different domains and we've got site link bridges and we're loading a lot of traffic on that. So again, from a performance viewpoint, performance is always a compromise. I want my replication to be faster and I want my WAN bandwidth to be utilized well, and that's the balance you have to play between those. And as soon as you start overlaying multiple domains onto your physical architecture, things do get complicated, and it does become easy to overload a WAN link, pretty rapidly. And even if you're not overloading it, you might wind up putting more replication traffic on it than you would like to be on there. So it's all about the compromise in these designs. The last thing we need to talk about is how Active Directory resolves conflicts in replication. For example, if a change to a particular user is made both at this domain controller and this domain controller, that change is going to replicate out to all the other domain controllers. And which one winds up winning? Well, there's actually a very complicated but straightforward, I guess, built-in architecture for determining that. Each domain controller maintains an update sequence number, or USN. And each one maintains its own, as well as a list of the update sequence numbers from other domain controllers that it's received. So each of these knows, hey, the last change I got from the LADC was number 20, and here comes 21. So Sydney, well, actually, let's say New York. New York's the one caught in the middle here. We made a change in LA, we made a change in Sydney. New York says, let's see, the last one I got from LA was 20. Now I'm getting 21. The last one I got from Sydney was 15, and now I'm getting 16 from it. So I'm going to keep 21, and LA's change actually wins. So that's the update sequence number. That will even override a locally stored, right? So again, let's say we make a change to an object, and that is LA's 27th change that goes out on the network. Someone in Sydney makes a change to the same user, and that's the 15th one it has sent out. Well, when this eventually replicates over to Sydney, the LA change is going to win simply because its USN is a higher number. Period. That's it. End of game. Now, it's certainly possible for two updates to go out on the network with the same version number. Who wins? Well, by default, the timestamp. In other words, the last change, the later one made, wins, even if it's by a millisecond. And that's why it's so important in an Active Directory domain to have good time synchronization between all of your servers. It's also important for authentication. The Kerberos authentication protocol only has about a 5-minute slip time that it allows for, meaning clocks can only be about 5 minutes out of sync with one another before authentication starts to not work anymore. So there's a couple of good reasons to have strong, good, solid time synchronization between all of your server and client computers across your entire network. Now, it's extremely unlikely that a change would go out on the network with the same USN and the exact same timestamp, but it's physically possible. So in that case, every change also gets stamped with a globally unique identifier, and Active Directory simply relies on that globally unique identifier to resolve the conflict. It's important to understand that you never really have the option of manually resolving Active Directory replication conflicts. It all happens behind the scenes. There's some log messages that you can get into if you've got auditing cranked up enough, and there's certainly things you can see in the operational logs for Active Directory to see it happening. But the entire process is automated, and it's really not subject to your influence, except that, you can do things like get the times out of sync and cause things to mess up that way. So you really can't fix it or control it. You can just make it not work properly by letting those clocks get out of sync. So I think we've covered everything. We've talked about how your site topology impacts clients' abilities to find the nearest domain controller, how your entire design is really just a balancing between WAN bandwidth utilization and replication efficiency, how to actually model your site topology using site links and bridges, and how Active Directory deals with the inevitable conflicts in replication. I hope this has been informative for you, and I'd like to thank you for viewing.